Hi everyone. At this video I will be introducing one of the experiments of physics lab course which is entitled as non-ohmic device in a circuit. The aim of this experiment is to investigate the non-ohmic behavior of a bulb which made of a tungsten filament and compare it to the resistor which shows ohmic characteristic. As it is known by the Ohm's law, current is directly proportional to the applied voltage. That means current increases or decreases at the same rate with the applied voltage. Here the important thing is the same rate. For example, when you draw current versus voltage plot, you will get a straight line. So the slope of that line will give you the inverse of the resistance, as the Ohm's law states. Let's put this aside and let me explain the non-ohmic behavior. But before that, I want to remind something about the material. Generally, the resistance of the material depends on the temperature with a thermal coefficient of resistivity. Due to the tungsten metal has a large temperature coefficient, the resistance of the bulb increases as the filament heats up. So, if the voltage applied on the bulb increases, the brightness and the temperature of the bulb will increase. So, the curve of the current versus voltage plot will not be a straight line. Why? Because the current does not change at the same rate with the applied voltage. So, the plot will be a parabola. Now, let me give you the general formula of the resistance related to the temperature. Yes. Using this formula, one can find the resistance of the bulb at the corresponding temperatures. Here, the alpha is the temperature coefficient, T is the temperature in Kelvin, T room is the 293 Kelvin, R room is the resistance of the bulb before the experiment, which you can easily find the value by using a multimeter. And R will be the resistance at the given terminal voltage. Now, let's move on to the experiment. First of all, we start by building the experimental setup. But before it, I should introduce the setup and the circuit elements. Here we have a DC power supply. We will use a resistor of 10 ohm. We will use a bulb of 5 watts. We will use 2 multimeters for measuring the current and voltages. And here we have an electrical board. And let me remind you something about that. These 3 banana type sockets are in contact each other. So each 3 sockets are separated. If you want to make connection between them, you have to use banana type connector cables. In this experiment, we will use also these cables. Now, I built the circuit according to the given diagram in the sheet. When we look at the diagram, we see that the positive pole of the voltage source is connected to the positive pole of the ammeter. And this will be my ammeter. And let me plug the connector cable starting with positive pole of the power source here, and I'm coming to the positive pole of the ammeter. So here the milliampere socket will be the positive pole of my ammeter. I plug it also. Then, now I'm at the negative pole. So here, the cone socket will be the negative pole. So using another cable, I plug here, and then this part is connected to the resistor. So let me insert the resistor on the board. For example, here. Then, for making connection, I will plug the cable here or this socket. I choose that one. And as you see in the diagram, the resistor and bulb in series. So I plug the bulb here. But pay attention, resistor and the bulb is not connected. So making this connection, I will use another connector cable, inserting like that. Now these two circuit elements is connected, but the circuit is not completed. Look, we are now at this terminal. So this terminal is connected to the negative pole of the voltage source. That means power supply. So using another cable, I plug here from the terminal of the valve to the negative pole of the power supply. When you investigate the diagram, you see that there are 2 voltmeters on resistor and bulb. But in this experiment, we will use only one multimeter to measure the voltage drop on both resistor and bulb. So, using the probes, let me show you. I will insert probe to the terminals of the resistor in parallel, like that. So now we are ready and the circuit is completed. Now let's operate the power supply. After completing the circuit, I will apply 1 volt terminal voltage to the circuit by adjusting this button. Yes, now it's 1 volt, and let me show you the current and voltage values. The current flowing through the circuit is approximately 58 milliampere, and the voltage of the resistor is 0.55 volts. If I want to measure the voltage of the bulb, I will change the probe's place and make a parallel connection with the bulb. And I measure the voltage of the bulb as 0.4 volts. Then I increase the terminal voltage as 2, 3, 4, 5 until 20 volts respectively. I will change and differentiate the change in current and voltage values. Let me show you something about that. Pay attention. Now I am at 2 volt, but the bulb is not glowing, so it is insufficient. But when I increase the voltage value slowly, for example, let's make it 5 volts, the bulb is apparently glowing. So, if you keep increasing the voltage values, you see the brightness of the bulb. It's increasing. So now, the temperature of the bulb is also increasing, and the resistance is also increasing. So, how can we differentiate that? By measuring the voltage and current values respectively at elevated terminal voltage values. For each values, let's turn back, we have filled the table. Now, let's look at the tables of the experiment. We will fill in these tables with the data obtained at the end of the experiment. We made the measurements from 1 volt to 20 volts. However, since we will send you different data, we want to make sure you understand the experiment and make the necessary calculations on your own. Now, let me explain briefly what you will do yourself. First, you should calculate the measured terminal voltage applied by the source for each current values. Second, you will make percentage error analysis with the applied and measured terminal voltages. This is for realizing the differences between the power supply and the multimeters. In addition, you will obtain the resistance of the bulb for each terminal voltages applied by the power supply. Now, you know the resistance of the bulb, so using the general formula of the resistance related to the temperature, calculate the temperature of the bulb. After these calculations, we want you to obtain the maximum applicable voltage to the bulb before it breaks out. Here, I will give you a hint. Just think about the melting point of the tungsten. Furthermore, you are asked to draw current versus voltage plots for the resistor and the bulb as seen on the screen. Do not forget to insert the equation of fitting curve with the value of R square on the graph. That's all. Thank you for watching.